Welcome to the second lecture in series of lectures of magnetic effect of current. In this lecture, we shall talk about some basic laws and some basic ideas about magnetic field and its impact. So, let's start with a remark. As we know that current carrying wire produces magnetic field. Here, in this video, we shall not delve deep into the mechanism of proof. We shall simply write the equations, the laws, and we'll solve J advanced questions. Okay. So current carrying wire produces magnetic field. So the first law that defines and talks about strength of magnetic field is Biot-Savart law. So let's talk about Biot-Savart law. So Biot-Savart law says that if there is a current carrying wire, okay, that carries a current I, then any small segment IDL, that's defined as a new vector, IDL, will produce a magnetic field at any point. Let's call this point P at a distance R. Then magnetic field strength of this differential element will be given as dB, and this would be equals to mu naught upon 4 pi into IDL cross R cap upon R square. So that's a very general equation, and there is nothing very difficult in this. This is very general equation. We'll understand this equation later with the help of few problems, but this is the general idea that magnetic field strength is directly proportional to this vector and inversely proportional to the square of distance, and this is the constant that's equals to 10 to the power minus 7. So that's and that is about Biot-Savart law, and there is another form to express this, and we express this in another form as IDL, and because this is a cross product, so the angle taken is angle between the distance vector and this IDL vector, okay, and so this is also expressed as IDL cross R vector upon R cube. I think this is trivial because if we convert this R cap is defined as vector upon modulus of R. So if you convert R cap into this, it will become this. So that's all about Biot-Savart law. Now we'll solve few questions on Biot-Savart law and we'll understand the mechanism of this particular law. Okay. So before solving some questions, let's talk about few general results. So the first result is that imagine that there is a wire of finite length, okay, and we have to find a strength of magnetic field at a distance, let's say R, at this point let's say P, and this subtends angle theta 1 and this is theta 2, okay, and this is 90 degree. We have to always consider this perpendicular distance. We can't consider this distance at any angle. This has to be perpendicular, only then we can use this particular result. So and then the magnetic field at point P would be, and if this carries current I, let's say I, then this magnetic field would be mu naught I upon 4 pi R, the distance, into sine theta 1 plus sine theta 2. That would be the magnetic field. And we know that if this, and if the special case is that if it is infinite, it's infinite wire, then this sine theta 1 and sine theta 2 will be 90 degree. This theta 1 theta 2 will become 90, and then this thing will become mu naught I upon 2 pi R. Okay, so that's a general result. Now we'll solve a few questions. So let's jump to the questions.